We are still with negations or negation of quantified statements. So these are like statements that had been modified by some quantifiers like all and there exists. Negations of quantified statements. So this is our second video for this topic. Okay, so example 1.32, derive the negation of the following statements. Let us bring back this table. This table will be our guide in deriving the negation of a statement which is modified by a quantifier. So how do we do that? Okay, so this one is a statement about x and y. Okay, so again, we shall read it in a way that is pleasant to our ears. For all integers x and y, x plus y is an integer, or the sum is an integer. Okay, so we shall now negate this statement. Okay, so our guide will be this. There is an integer x and y such that p of x is not true. Okay, so the negation of that statement is there are x and y, or there are integers x and y such that x plus y is not an integer. Another one. For all real numbers x and y, where x is not equal to 0 and y is not equal to 0, if x times y is equal to 1, then y is equal to 1 over x. Okay? So we shall negate it. Okay? Our guide is still this one. So the negation, how do we read it? There are real numbers x and y. X is not 0, y is not 0, xy is equal to 1, but y is not equal to 1 over x. Another one. For all real number x, where x is not 0, there is a real number y such that x times y is equal to 1. We shall negate it again. There is a real number x. It is not equal to 0, but there is no real number y such that x times y is equal to 1. Okay? We can write it in this form. Okay, so there's another form for this. So I will read again the original statement. For all real number x, where x is not 0, there is a real number y such that x times y is equal to 1. So this one is another negation. Another form of its negation. There is a real number x. It is not equal to 0, but for all y, or for all real number y, x times y is not equal to 1. So these two statements are the equivalent. They are the same. They are equivalent statements to the negation of our statement here.